Kia ora koutou, ko Anita Wreford tōku ingoa. So just a brief introduction about myself. I am a professor at Lincoln University in the Agribusiness and Economics Research Unit, but as well as that I lead the Impacts and Implications program within the Deep South National Science Challenge. I'm not sure, I imagine most of you are familiar with the National Science Challenges, but if you're not, there are 11 and they are set up to answer questions that facing New Zealand's society. And the Deep South one is about climate change, impacts and implications, not mitigation. And I'm going to share, I guess, some of my insights from that challenge, but also a range across other ranges of funding mechanisms. And just a note, I guess, that the National Science Challenges will end next year, and so it is going to potentially leave quite a hole in our funding landscape. I'd also like to just echo everyone else's acknowledgement of the devastation that the weather and the climate has caused this year, really, across the North Island, and my thoughts are really with those people affected. And we appreciate those of you who swam out to come to this this talk or this conference today. So I was asked to speak about the impacts of climate change on New Zealand's agricultural sector, and I just thought that we could step back a second before we leap into that, just to think about what impacts are. And sorry that that's probably a little small for most of you to see, but it's the Intergovernmental Panel on Climate Change frames risk as the intersection between the climate hazards, exposure and vulnerability. So it's not, often we might think of impacts as the climate hazard itself, but it's really how that interacts with the whole system. That is what causes the risk, and then if that risk is realised, the impact. So if we just think about exposure for a minute, we have this is really about reflecting what is in the place of some of these climate hazards. So some research that the Deep South has funded, and there's other research going on, has looked at mapping flood risk. And so this just illustrates, and please don't look too closely or try and pick out any of your properties, but just illustrates that here we've got the hazard interacting with where farms are. You can go down to the farm level if you want to identify whether that farm is in that exposure level or area. But that's not the whole picture either, because we need to also think about the vulnerability. So in the literature, we kind of think about it as the combination of the sensitivity of the land, so whether it's very steep and the soil type and quality and the vegetation and things like that, that will determine how those hazards interact and cause the impacts. And also the adaptive capacity of the farmer. And I'm not talking about adaptation in this talk today, although it is the main area of my research. But this really influences how those hazards transpose into impacts on the farm. And I think it's really just important to bear that in mind. I was going to flick through some of what we know about the climate trends, what we're seeing already, but in the interest of time, I might not spend too much time on this, but just, we can see what we're experiencing already, and these are some of the observed impacts documented in the IPCC Australasia chapter of the most recent report. And then we know we have projections of future climate for New Zealand. And again, I won't spend too much time on this. If you are interested in obtaining more information about the climate projections, please contact me or look at the Deep South website, and we can put you in touch with people who can help you in that regard. But I'm just going to spend a little bit of time talking about what these climate projections mean for agriculture, and in a maybe wider sense than we might be thinking about when we just look at the increases in rainfall patterns and things like that. And I'm picking a snapshot of research here, so I don't have time to reflect all the research that's gone on in this area in New Zealand, so please just bear that in mind. Probably the most studied impact in New Zealand is the impact on pasture growth. So I've just picked a figure from a recent paper that looked at the mean annual pasture yield, and this happens to be in Southland. This study looked at a range of areas, and this is Southland. And you can see, well, you probably can't actually because it's quite small, but I'll explain that the darker blue colours are an increase in pasture growth, and we've got different climate futures. So we've got a high emission scenario on the right, a mid-range in the middle, and a low emission scenario on the left. So this actually indicates that farmers in Southland might experience more pasture growth under a high emission scenario. But it's really important to recognise that this is the mean across the year, and the changes that will probably have the biggest impact on farmers are the seasonal changes, and we're already seeing changes in seasonality and pasture growth in different areas, and the picture will be different across New Zealand. But just trying to be optimistic, I guess, in contrast to some of the pictures that we're hearing. Another piece of work that is co-funded by the Deep South National Science Challenge and Our Land and Water, and Richard will talk maybe a bit more about this in his talk, but it's looking at land use suitability under climate change and potential opportunities. And so this is a website, actually Linda Lilburn has a poster here which you could go and look at if you wanted to understand more about it, but it's building on work that was carried out a few years ago looking at climate change impacts on land use suitability. And now they look at a range of crops and how the climate will influence where they might be best grown. So on this website that I showed, you can go in there, anyone can access it, and you can find these fact sheets that show the suitability in the future. I've just picked out kiwi fruit as an example, and of course you can't really see what this means, but yellow is very suitable and pink is unsuitable, and I think this is in a high emission scenario at the end of the century. And you can see that they've looked at these different criteria to determine this. Other work is looking at the impacts on erosion and sediment load, which is particularly probably relevant at the moment, unfortunately. And a research paper has just come out this year summarising, I guess, the findings. Again, this is from the same project. And you can, well, the dark purple colours are the increase in sediment load, and by 1990, and the map on the right is the high emission scenario. So you can see in that situation, there's quite high increases in potential sediment load. But again, you know, this, I guess, is just what would happen if we didn't adapt, and so I think we might hear a bit more about adaptation later. So these give us a picture of what might happen, and there's other work that's occurring on heat stress, looking at pests and diseases, facial eczema and things like that. As I say, I can't represent it all here. But what does this mean for our farm businesses? In a project that I am leading, which is also funded by the Deep South with some co-funding from Dairy NZ, they've taken the pasture growth projections and looked at feed demand and looked at where there might be a deficit between pasture growth and feed demand to get an understanding of what that might mean for farmers. And again, we've got mid-century on the top row, end of century on the bottom. There's optimistic and less optimistic, which relate to there are 6 models that are used, and some are grouped into the more optimistic futures. And you can see that in the less optimistic ones, there's actually quite a deficit between the pasture and the demand. And we're also in that project looking at what farmers might do, what other types of pasture they could grow, what kind of feed they might need to make up that deficit. And in that project as well, we'll then look at the impact on milk yield and some of the economics, because that's also part of the impact of climate change. Another study from a couple of years ago now looks at the impact of drought and climate change on farm profits, and it really shows that if, the top one of those top dashed lines is just using soil moisture, but if you consider other climate variables, which is that more sharply curved red line, the taxable profit for sheep and beef farms at the end of the century would be 54% less as a result of drought and climate change than in 2016. So just trying to keep that big picture, or recognise that we can look at the impacts on farm and the biophysical impacts, but they have implications through the farming system. And then another project that I was involved in, which was funded by MPI's SLEMAC fund, looked at what if New Zealand is experiencing a drought, but the rest of the world is also experiencing significant breadbasket failures, which means basically concurrent droughts in many of the major producing regions. And again, I mean, don't worry too much about the numbers, but it shows that because of the reduction in supply, the trade price actually increases. So farmers' profits might increase. This masks, of course, the fact that consumers have to pay for higher food prices, and that's a global issue for food security as well as in New Zealand, and the distributional impact could be significant. But again, just recognising that we sort of operate in a very large system. It also doesn't consider the effect on farmers themselves of having to go through the drought. So although they might receive higher returns, they've had possibly a very traumatic experience. And so we also need to consider the social impacts. And some work that is part of this other research that I showed looking at the biophysical impacts actually also looks at the social impacts on farmers and understanding how climate change is impacting them and what they're planning on doing about it. And there's been a little bit of other work on the social research in New Zealand in different sectors, but I would say it's a bit neglected compared to the biophysical side of things. So we are developing a better understanding of the impacts of climate change on agriculture, but impacts are complex. We heard Andy, I think, this morning talk about we really don't understand how they will interact with each other. They might occur at the same time. They can potentially cascade and amplify if we don't deal with them effectively at the time. And so we've got a little bit of research looking at this idea of cascading impacts, but I think we need to broaden out to consider multiple impacts and how they interact with each other. So I'm racing through this because I feel I've got only 1 minute left. So I will just finish on saying that although there are gaps in our understanding of impacts on climate change on agriculture, I actually feel that we have quite a good understanding of the general direction, and what we really need now is more knowledge and understanding about adaptation, because we're starting to experience these impacts now. We need to understand what adaptations are effective, how long they'll be effective for. We need to be able to monitor them so that we have evidence to, I guess, go out to our farmers and give them confidence to try these adaptations. And in some cases, we'll need transformation of our systems so that they can deal with this changing climate. So I'll leave it there. Thank you.